Okay, so here's a video about implicit differentiation. So what this is about is that this is about finding a derivative if y isn't really given as a formula in terms of x. It's like you have an equation involving both x and y. Sometimes you can solve this equation for y, sometimes you can't. In this one, we could solve it for y, or at least, let me tell you what I mean. I can solve it for y like this. And yeah, maybe I shouldn't say I solved for y. I got two possible answers. There's the plus and the minus, but I basically solved for y. But in any case, implicit differentiation is good for situations even when you can't solve for y, and you don't need to solve for y. So maybe I'll forget about this part. Anyway, here's what you do. I'm going to take this equation, and I'm just going to take the derivative of both sides with respect to x. And let me, since this is my first time doing this, well, it's not my first time, but I'm literally just taking the derivative of both sides with respect to x. So the derivative of x squared, we know how to do that. That's just 2x. Now what happens when I do the derivative of y squared? Keep in mind I'm doing the derivative with respect to x. So the derivative is not just 2y. What I have to do is I have to do something like the chain rule. The derivative of this would be 2y, but for the chain rule, remember you have to multiply by the derivative of the inside. The inside function here is a y, and the derivative of y is y prime. So 2y times y prime. And the derivative of a constant is just 0. And then I take that and I just solve it for y prime. So I get that over, so y. So I guess a 2 will cancel and I get negative x over y. Oops, that's y prime. Okay. So that's it. But let's do more examples. So what about something like this? I'm going to do the derivative of both sides with respect to x once again. And eventually we'll get to the point where I won't even write this first step down, but I just want to remind you I'm doing the derivative of both sides with respect to x. So what do I do with something like this? This is like the product rule. So let me do the easy part first. I do the derivative of x, which is just 1. And then it's going to be x times the derivative of y squared. The derivative of y squared is, we did it before, it's just going to be that again. The derivative of y squared is 2y times y prime. Okay, and then I move on. I've got to do this part. This is another product rule, so derivative of x squared is 2x times y, because I leave that alone, plus x squared times the derivative of y. The derivative of y is y prime. And that would equal 0, because that's the derivative of 3. Okay, now I want to solve for y prime, and this is not as bad as it gets, but this is a common theme here. I'm underlining the parts that have a y prime on them. So here's what I'm going to do. Everything that doesn't have a y prime on it, I'm going to move over to the right. With what's on the left, I'm going to factor y prime out. So if I factor y prime out of these two underlined things, I'm going to have 2xy plus x squared. And that's going to equal this stuff that I moved over here, negative y squared minus 2xy. finally I solve for y prime by just dividing by this. Okay, let's do another one. So for this, doing the derivative of e to the xy, I have a chain rule. First, the derivative of e to the whatever is just e to the whatever. But for the chain rule, I would multiply that by the derivative of the inside. So then what's the derivative of xy? Well, now I have a little product rule. Derivative of x is 1 times y plus x times the derivative of y is y prime. Plus, okay, so this is just a 2y squared. We already did the derivative of y squared a couple of times, so this is going to be 4y prime minus 1 because the derivative of x is 1 equals 0 because the derivative of 1 is 0. Okay, now I see y prime in two places. It's here and here. Unfortunately, this one's inside parentheses multiplying something else, so let me go ahead and just multiply everything out because I don't like that. I would like to separate this from this. Okay, so y e to the xy, because that's this times this, plus y prime x e to the xy, because that's this times this. Okay, now y prime is here and here. I'm going to do the same thing I did last time. Everything that doesn't have a y prime is moving over to the right. Y prime will get factored out of what's left. Like that. And now I just divide by this. Oops. All right. We can use this stuff to find a tangent line. Of course, y prime tells you the slope of a tangent line, so we would just find y prime and use that to find our tangent line. So let's do this one. So I'm doing the derivative of both sides with respect to x. So I get 2x minus, and now I'm going to carefully use parentheses because I'm about to do the product rule, and I don't want to forget that this minus sign has to go to both parts of the product rule. But the derivative of xy is 1 times y plus x times y prime. Right? Yeah, I chose a lot of examples that involve y squared, but so the derivative of y squared is 2y times y prime again, and that equals 0. Now, let me tell you something to make our lives easier. What I could do is I could solve for y prime just from here. However, there's nothing about this example that requires me to have a general formula for y prime. I really only care about y prime at this point. So what I can do is I can plug these specific numbers in for x and y, and then I'll have an equation with, well, let me just write it. So x is 2, y is 1, so I've got 4 minus, maybe I'll also simplify as I go. 4 minus y, 1 minus xy prime, so that's 2y prime, minus 2y y prime. Okay, y is 1, so that's another 2y prime equals 0. Now it's a lot easier to solve for y prime. I just have a bunch of numbers. So this is 3 minus 4y prime equals 0. So I would get this over and divide. Y prime would be 3/4. So that's the slope of the line. Here's a point that it goes through. So y minus 1 equals 3/4 x minus 2. Okay. So let's do an example where we find a second derivative. First, I'm going to find the first derivative, and that part is what we've been doing. So 2x plus, and then the derivative of xy is 1 times y plus x times y prime plus 2y y prime, and that's the y squared, equals 0. And now I'll solve for y prime like I've done a few times. So y prime is here and here, so I'm going to factor y prime out of this stuff. This moves over here. And finally I solve for y prime by dividing by this. Okay, now how do I find y double prime? Well, y double prime is just the derivative of y prime, so with respect to x, so I'm just going to do the derivative of both sides with respect to x, and that'll be y double prime. Okay, it looks like we have the quotient rule here. How do you do the quotient rule? The easy part is the bottom. So, okay, in the top I'm going to have bottom times the derivative of the top. So what's the derivative of the top? The derivative of the top would be negative 2 minus y prime, right? And then I'm going to subtract the top times the derivative of the bottom. The derivative of the bottom is 1 plus 2y prime. Right? And what I would like to do is I would like to write my answer without any y primes in it. So what I'm going to do is I'm going to take these y primes and replace them with the answer that I got for y prime. So this is x plus 2y times negative 2 minus this. Minus this times 1 plus 2 times y prime, and y prime again gets replaced with this. Okay, I am going to leave my answer just like that. I should point out you can simplify this a bit more. Usually one thing I complain about is fractions inside of fractions because I generally don't like them. You can get a common denominator with all of this, but you can do the algebra if you want to simplify it. But the calculus part is done. We're done doing derivatives. If you need to simplify it, then go ahead. But so I'll leave the answer like that. And yeah, that's probably about it for this video.